So 3.6 is about story problems. I want to give you, one of the challenges of story problems is that they're all different. But there is one thing they ask in this section that's kind of the same in every story problem. They typically say, somewhere in the problem, they end with this command of you. Express so-and-so as a function of such and such. What does that mean? Let's say, suppose they said express, I don't know, P as a function of Q. What that means is you're supposed to find an equation that looks like this. P equals something that depends on Q, some formula that depends only on Q, some function of Q. So let me do an example. So I'm going to set up the story problem here. Let's say I've got a trapezoid. A trapezoid is a four-sided figure with two sides that are parallel. Let's say the base of the trapezoid is along the x-axis, and it's got two vertical sides, there and there. Let's say that's a little vertical line segment at x equals -1, and this is one at x equals +2. And up here, the fourth side of the trapezoid is this line, let's say it's y equals 1 plus 3x. My trapezoid is all in black. Let me write it in blue here, maybe we can see it a little better. And here's what I'm going to do in that trapezoid. I'm going to inscribe a triangle inside it. I'm going to make a triangle whose base is this entire thing here. And then it goes up to one point on the sloped top of the trapezoid and back down. That's my triangle. I don't mean to suggest that it actually has to touch the line at x equals 0. It touches it at some point xy. And so here's the challenge. Express the area of that triangle as a function of, let's say, x. The x coordinate where the top of the triangle touches the roof of the trapezoid. Right? So what I'm looking for is some answer that looks like this. A equals something that depends on x, something depending entirely on x. So let's see, what is the area of a triangle? So I write down the first thing I know about area, it's base times height. Well, that doesn't depend on x. Let me think some more about it. What's the base of that triangle? It's 3, isn't it? It extends from x equals -1 to x equals 3. X equals 2. So that distance is 3. And that's the base. So that's 1/2 times 3. What's the height? Well, the height is just the height of that point. So it's y. Okay, I still haven't expressed this area as a function of x, but at least I've got an expression for the area. What's y? Well, y is a point on this line. And on that line, the y coordinate equals 1 plus 3x. 1/2 times 3, that's 3/2, isn't it? So y gets replaced with 1 plus 3x. Ah, I'm done. I've expressed area as a function of x. But what if they ask me something different? I'll say, as above, express area as a function of y. I think I left myself enough room to do that one because we have it up there. Do you see what it is? Yeah, we were actually done right there. If that was the question, area equals 3/2 y. All right, so The thing about story problems is you have to read them and translate what they've said and maybe some of the pictures they've given you into more pictures and some calculations, but you also have to understand your goal. So look for the phrase, express so-and-so as a function of such and such. That's about the most common thing that occurs in all those problems. Let's try another example. I'm going to use the same setup as before, that same trapezoid. This time, when I put the triangle in, same green triangle, its base covers the base of the trapezoid, and it goes up and touches this slanted line that's the top of the trapezoid. Let's say I want to express the perimeter of the triangle. Let's say as a function of its height. So the height, remember, is the distance from the top of the triangle down to the base. And this was the point xy along this line. This line was y equals 1 plus 3x. So the height is that distance, it's that y coordinate. So what's the perimeter? Well, the perimeter is the distance around a thing. So it's the sum of these three lengths. It's that length, the bottom leg of the triangle, plus that length of that side with positive slope, and the length of that side that has negative slope. I know what this one is because this was the point x equals negative 1, y equals 0, and this was the point x equals 2, y equals 0. The horizontal length of that triangle is just 3. This distance is from here to here. It's the distance from the point negative 1, 0 to the point xy. And that's what that one is, from negative 1, 0 up to xy. And this distance is the distance from xy to the point 2, 0. This looks like a job for the distance formula. That's 3 plus the distance from that to that is the square root. X minus a negative 1, so that's x plus 1 squared, plus y minus 0 squared. And then plus the distance from that to that. That's x minus 2 squared, plus y minus 0 squared. Okay, so there's the perimeter. But it's expressed in terms of x and y. I'm told to express it entirely in terms of y. So the y's are okay, it's the x's I have to get rid of. So again, I'm going to use the fact that there's this relationship between x and y. X and y can't just be any old thing. Y has to be 1 plus 3x. It's the x's I want to get rid of this time. So I'd like to know along this equation, what is x? So along that line y equals 1 plus 3x, can I express x in terms of y? Well, that just means solving for x. So 3x is y minus 1, so I divide by 3. X is 1/3 y minus 1. I'm going to take that and put it in for the x's here and here. So the perimeter is 3 plus square root of, let's see, in place of x, it's 1/3 y minus 1, and plus 1 squared, plus y squared. Double check I've got that right. There's x, plus 1 squared plus y squared. And here in place of x, I'll put this again. It's the square root of 1/3 y minus 1 minus 2 squared plus y squared. And I could FOIL this out and collect up terms, but I think it's reasonable to say that we're done.